Welcome to Lesson 3.1, Dividing Fractions. We are going to work with fraction division in both a model sense and also using multiplication by the reciprocal. Or, again, freeze, change, flip, or keep, change, flip is what the students have learned. So taking a look at this assignment from Lesson 3.1, the first section here on the first page tells us to divide, express the quotient in simplest form, use the models to help you. So here we're really checking to see if the students have developed an understanding of the models and how to use them. So for number 1, it says we have 2 divided by 1/3. If you notice, they've drawn us 2 whole bars. So this is what we would expect students to draw if a model was not given. So 2 whole bars. The next thing that we looked at is this denominator of 3. The denominator tells you that we need to break each bar into 3 equal parts. So I always point to this denominator in the student notes and I remind them that this means how many parts. And notice there's 1, 2, 3 parts in this bar, as well as 1, 2, 3 parts in the second bar. Well, the top number then is what we really haven't used yet. It's the last thing that I refer to when we're using models, and it tells us how many to put in a group. So 1 per group. I'm trying to make groups of 1. So this first box or part would be considered one group of 1/3. This second group right here in the middle would be considered my second group of 1/3. I can make a third group right here of 1/3, and I also have a whole nother bar to work with, and I would anticipate that I could make 1, 2, 3 more parts or 3 more groups of 1/3. So this could be 4, 5, and 6. My final answer is actually 6, although my pen won't let me write that for you right now. So we'll try again here. 6. I was able to make 6 groups of 1/3. So I tried this strategy. Sometimes the students prefer to shade, polka dot, shade to kind of keep track of their groups. Or sometimes you can write right inside here just to show us that you're keeping track and using that model. For number 2, we're going to scroll there next. We still have a whole number. We're still starting with a whole number of things, 3, and we're dividing by 1/6. So that denominator is a little bit different for us this time. So if you'll notice, they drew us 3 whole pizzas, or pies if you will, and they divided them each into 6 parts. The top number then says go ahead and put 1 per group. I typically would not draw this pie model. I would instead draw a bar model, but we can use what's here and try to make it work for us. If I get to put 1/6 in every single group, this would make a group, this would make a second group, a third group, a fourth group, a fifth group, a sixth group. And I have a whole nother pie to work with here. So I'd have 7 groups of 1/6, I'd have 8 groups, 9, 10, 11, and 12. And I still have this extra pie to work with, so counting on 13, 14, 15, 16, 17, 18. I was able to break 3 into little tiny 6, and I was able to make 18 of them. 18 is my answer. Let's take a look at this next model, if you will. Notice they've already drawn the whole number for us. They've already drawn 2 whole bars. That's what these represent here. Here's 1, here's 2. Now I want to take these 2 whole bars and split them into how many parts? Well, remember that comes from our denominator. So here we have a 5. I want to see 5 parts in each bar. So they've done that. They've taken this and split it into 5 equal sections. 1, 2, 3, 4, 5. And this one as well. Well, I've paid attention to the whole number. It helped me draw my bars. I paid attention to the denominator. It helped me split it into equal parts. But now this numerator is different than what we've seen on this worksheet so far. If you notice, it's a 2. So what that means is I want 2 per group. I'm trying to make groups of 2/5, not just 1/5, but 2. So you can kind of see by the shading that these first 2 are shaded a little bit more heavily. It's kind of like saying this one plus this one makes my first group. These lighter shaded ones, well, 1/5 plus another 5th makes 2/5. This is my second group of 2/5. I'm going to go again, but notice I have this extra piece sitting here. If I combine it with the one next door, I would have 3 whole groups of 2/5. And if I keep on going with this idea, I need 2 of them to make my 4th group and 2 more of them to make my 5th group. We can make 5 equal groups of 2/5. For this last one, we're given a model of 6 whole pizzas or pies, and these 6 whole pies are being divided into groups of 3/5. Well, before I can go to the 3/5, I pay attention to my denominator. I need to make sure that there are 5 parts in each of my models. 1, 2, 3, 4, 5 looks good. 1, 2, 3, 4, 5. Yep, they've already split these fifths for us in all of the models, all of the whole pies, if you will. Well, the next thing we pay attention to is our numerator. The numerator here tells me I want 3 per group. I'm trying to make groups of 3/5, not just 1/5, but 3/5. So I could take this one, and this one and combine them, and that would make my first group. So we could put a 1 in each of those. They go together to make the first group. Notice I have 2 extra pieces here, but I encourage the students never to throw out pizza or chocolate or whatever it is that we're pretending we're working with. So in that case, we would take these 2 pieces and combine them with this one close by. I still need a group of 3/5, so 1/5, 2/5, 3/5. This would make my second full group. This dark shading here shows you that they took these 2 plus this 1 to make 3 more fifths, or our third group. What about this extra piece? Well, we'll combine it with some other pieces next door, so this would make our 4th full group. And continuing with this idea, 5, 5, 5, this will be group 6, this would be group 7, don't forget to add another piece to that. We still need 3 pieces combined to make our 8th group, and here we have our 9th group started and finished in the second model close by. And the last thing we have are 3 remaining pieces, which is perfect because that will give us another group of 3/5. How many total groups did we make? The answer would be 10. We made 10 total groups. We're going to scroll to the next page here, and I'm going to show you another way of thinking of fraction division. So we don't always have to use a model approach. Sometimes we can use something called multiplication by the reciprocal, or reciprocal method. On page 2, I gave the students their option. I said, for number 5 and 6, you may want to use Kcf, also known as keep, change, flip. Or you might want to try the model. Either one should work. Now the models I just think get more complex because if you notice, we don't have a whole number to start. We just have a fraction for both of them. So that's what they tried to draw for you here. They tried to show you one whole bar would be this long. But inside that bar, they only shaded half of it. Well, when they were done shading the half, they had to split the bar into 4 equal parts. So that's what they went back and did. They split each half down the middle to get 1, 2, 3, 4 parts. But we want 1 per group. Oops, easy for me to say. 1 per group. That should say group, by the way. So if you look here, each of these fourths makes a group. So this right here would be my first group, and this right here would be my second group. And you might say, why don't I keep on counting? Well, if you notice, my dog ate those yesterday. I joke with the students that those pieces are already missing. The answer here would be 2. Now this model I think is more challenging because again, you're working with 2 fractions. There's no whole number to start. So the students have also learned this Kcf approach. So if my original problem said 1/2 divided by 1/4, I could keep, change, flip to also get there. If I take this 1/2 and keep it, it's going to look the same. If I change my division, I change it to its opposite, which is multiplication. And the last thing it says is to flip, or show us the reciprocal is what it would be called. So I show the reciprocal of 1/4 is 4/1. Notice those numbers switch positions. I'm really ready to multiply the 2 fractions. The thing that I noticed is that maybe I have some cross simplifying. Is there a number that divides into 2 and 4 nicely? The answer is yes, 2. I can make these numbers smaller. So we've been working on this with students a bit, something that they should have seen as 5th graders, and we want to kind of continue here because it's going to make their job a little simpler as they're trying to make numbers smaller and get to final answers. Well, there are 2 2's and 4. 4 divided by 2 is 2. So I have a new numerator here. And 2 divided into 2, it goes 1 time, so I have a new denominator. I don't really need to cross simplify here with my 1's. If you notice, I like to say the 1's are as low as you can go. It's kind of like the limbo. So I still have 1's for my numerator and my denominator here. I'm ready to multiply straight across because when we multiply fractions, that's a general rule. Numerator times numerator, denominator times denominator. And actually 2/1 ends up being the same as 2 whole groups. All whole numbers could be written over 1 in fraction form. So we take that 1 away to write it as a whole number again. We're going to do the same thing here with number 6. So for number 6, we're starting with a fraction, and I'll look at the model with you first. But again, I think students are probably going to struggle with that idea a little bit, so don't be upset with yourself if it's not making a ton of sense. This is harder to picture or visualize. We don't have a whole bar. We only have 2/3 of it. So we have this bar that they've drawn for you. That dotted line is kind of showing you, well, what the dog ate yesterday. What part is missing? But I'm going to draw the whole thing in for us for a quick minute. And it says that I want 2/3. So I need to split this first of all into thirds. That's what those dark lines represent for you. Notice that I have 1, 2, 3 total parts. If I just think about thirds. Well, they also shaded some in for you. They went from here all the way to here to show you that 2 of those thirds are still present. 2 of those thirds are shaded. The next thing we'll want to do is tune into our denominator of the second fraction, and remember, what does that tell us? Oh, that tells me how many parts I want to make. So I need to turn these thirds into ninths. I can understand that the pieces must be getting smaller. I still have the same size bar, but I'm giving you more parts. So what they did is they took each of those thirds and split them so that they have 1, 2, 3 smaller pieces. 1, 2, 3 smaller pieces, or 1, 2, 3 smaller pieces. So that would give us 3, 6, 9 pieces, but again, they're smaller. We made 9 parts. The last step says we want to put 6 per group. We're going to try to count up how many groups of 6 ninths we could make. So I'm looking for 6 to go into a group. 6 of those ninths. Well, here's 1 ninth, 2 ninths, 3 ninths, 4 ninths, 5 ninths, 6 ninths. All the way from here to here, I have 1 group. Well, I don't have any extras, so the answer is actually just 1. Again, this model might be difficult to work with, so let's go ahead and try the reciprocal approach. Let's try to take 2/3 divided by 6 ninths and handle it with a keep, change, flip. Well, if I keep the first fraction, it's going to look the same. I keep it as 2/3. But when I change my division, I think of its opposite. I move to multiplication. And the opposite, in the flip of 6 ninths would be 9/6, also known as its reciprocal. That's why it's called the reciprocal approach. We are really ready to multiply. But if you remember a moment ago, I showed you something important. Some 5th grade teachers called it the boo-boo method, the Band-Aid method, or maybe the butterfly method. So we're going to look for some cross-simplifying. That's really what this is called. If you look at your 3 and your 9, they both share a common factor of 3. We could simplify both of these by 3. Well, I know 3 goes into 9 3 times, and I know 3 goes into 3 once. If I look going the other direction, cross-simplifying the 2 and the 6, do they share any common factors? Well, in fact, they're both even, so I know I can divide them both by 2. 2 goes into 2 1 time, and 2 goes into 6 3 times. And I'm ready to multiply across. Numerator times numerator. 1 times 3 is 3, and 1 times 3 in the denominator is 3. And this isn't the answer I had a minute ago, is it? But I hope you recognize that 3/3 really means I have the whole thing. That's the same thing, or equivalent to 1 whole. For this next section, through the end here of this page, I asked you to do some modeling for the first 4, and then go ahead and use our abstract method, that keep, change, flip, or reciprocal approach, for numbers 11 through the end of this page, or the end of this packet actually. So I'm going to show you just a couple of these models to see if we can get you going in that direction, because that's the harder, maybe more challenging visual approach for kids, but it also helps them to see where those answers are coming from. So numbers 7 through 10, again, I'm looking for a model. So I'm going to kind of skip around here for you. I think I'll take a look at numbers 9 and number 10. In particular, because their numerators are kind of special. I think that could be challenging for us. So for number 9, I'm supposed to draw how many whole bars? 3. So I want to see from you that you draw me 3 whole bars. This is a pictorial approach, a picture approach. Now take a look at this denominator. It tells me I want to make 5 parts. So if you hold up your 5 fingers for a quick minute, so I'll trace my lovely hand for you. How many gaps do we see in between our 5 fingers? There are 4 gaps. It tells me that I need to make 4 lines. So 1, 2, 3, 4 would give me 1, 2, 3, 4, 5 parts. If I go again, I'll draw 4 lines, 1, 2, 3, 4 in this bar to make 1, 2, 3, 4, 5 parts, or fifths. And I'll do it again. 1, 2, 3, 4 lines makes 1, 2, 3, 4, 5 parts. Perfect. But the last thing we need to tune into is how many per group? 3 per group. So I have students that like to shade these. We could try it. We could try shady, 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 polka dot, polka dot, polka dot. Or we could just try to number them. Really your choice. So I think because I see a lot of students shading, I'll give that a try for you. We're going to put 3 of these fifths in a group. So here's 1, 2, 3. That's 3 fifths. I just made 1 group. Let's go again. Polka dot, polka dot. Oh, I'm short 1. I'll grab from the next bar and make that my second full group. We're going to go again, but this time I'll shade so that you can tell where my groups start and stop. So shady, shady, shady. Looks like I can make 3 groups. And I'm not done yet because there's still a little left here. So I'm going to go polka dot and polka dot from the next bar so that I still have 3 fifths going together to make my 4th group. And last but not least, shady, shady, shady. Ooh, this one worked out really nicely. I didn't have anything left over. Looks like I can make 5 full groups. That is my answer, 5. I want to take a look at this next one, number 10, with you, just to give you an example of how to get this model going. So it says that we need to start with 4. So I should see you draw me 4 bars. I'm going to make these a little bit bigger because it seems to say that I'm going to make 7ths. And I know 7ths are a little harder to show if they get too tiny. So I'm going to try to make sure we have room to work. Well, if you hold up 7 fingers, you'll now notice that if you count the gaps in between, there are 6 gaps. That tells me I need to make 6 lines. So we're going to go 1, 2, 3, 4, 5, 6 lines. Should make 1, 2, 3, 4, 5, 6, 7 parts. 1, 2, 3, 4, 5, 6 lines gives me 7 parts. 1, 2, 3, 4, 5, 6 parts gives me 7 lines. Oops, wrong thing. 6 lines gives me 7 parts. 1, 2, 3, 4, 5, 6 lines gives me 7 parts. I have these 4 whole bars. There's no shading needed at this point, and I've split them into 7ths, or 7 parts each. So next I need to group them by 2s, 2 per group. I'm going to try my counting strategy here. So I know I'm going to try to put 2 of these together. So this one and this one, 1, 1. That'll make my first group. 2 more combined will make my second group. The next 2 put together makes my third group. What should we do with a spare? Oh, we can add it to the next bar. This makes my 4th group. 2 more put together makes my 5th group, and my 6th group, and my 7th group, and so on. Group. If you notice, we were able to make 14 groups of 2 7ths. I was able to break 4 whole bars into 14 groups of 2 7ths. That's my final answer. On number 11 and 12, I will show you the reciprocal method just to kind of help you review that. And then I'm going to set you loose on the rest of the worksheet because I think you're going to be ready for that idea. So scrolling just a little bit here so that we can see 11 and 12 a little bit better. Again, you could try a model approach, but notice that we have a fraction divided by a fraction. So I'm going to encourage you to try our shortcut. This is kind of a hoop that we can jump through. It is an abstract rule that will always work. It's also called multiply by the reciprocal, but we affectionately call it keep, change, flip, just to help students remember it, Kcf. Let's keep the first fraction. 4/5 stays the same. What do we change division to? It's opposite, or multiplication. And if I flip 3/10, it's going to look like 10 over 3, also known as a reciprocal. And then I'm ready for multiplication rules. Do you see any cross-simplifying in this problem? I hope you say yes. If you notice, this 5 and this 10 definitely share some common factors. They both divide by 5. You can check your multiplication chart and see if you see 5 and 10 in the same row. And there they are, they're in the 5 row. Well, 5 goes into 10 twice, and 5 goes into 5 one time. This 4 and this 3, you can check your rows all day on your multiplication chart, but you'll see that they're only in the 1 row. They don't have much in common besides the GCF of 1. So for that reason, I'm just going to leave them alone and multiply across. Numerator times numerator gets me 8. Denominator times denominator gets us 3. And this wouldn't be a final answer, 8/3. This is an improper fraction, so we need to make sure that we turn it into a mixed number. Now, because we've been doing this flip with freeze change flip or keep change flip, students like to flip this as their answer. Don't do that. That will get you in trouble every time. You'll get a wrong answer out of that. 8/3 means I have more than one whole, and if you were to flip it, 3/8 sounds like smaller than 1/2 of something, so that won't work. Instead, we take the numerator and divide by the denominator. I'm trying to figure out how many whole groups I can make. 3 goes into 8 twice, because 2 times 3 is 6, and when you subtract, there's 2 left over. If you go around what I like to call the ring of fire, you're ready to write this as a mixed number. So the first thing we read comes from the top, that becomes my whole number, 2 whole groups. And I'm left with 2 tiny pieces out of the groups of 3 I was trying to make, or out of the 3 parts that the denominator kind of stays the same here, doesn't it? 2 2/3 is the final answer. We're going to try the next one with a keep change flip. So notice we're going to keep the first fraction, 9/10. I'm going to change from division to multiplication, and next I'm going to flip 7/20 to its reciprocal, 20/7. Do you see any cross simplifying possible here? I hope you'd say yes. The 10 and the 20 seem to both end in 0. That means that they'll both divide by 10. If you check your multiplication chart, there they are. They're both in the 10 row. 10 goes into 20 twice, and 10 goes into 10 one time. What about 9 and 7? Well, you can check your chart. You can look down the same column or across the same row. You'll see that they show up in the ones column. The greatest common factor of 9 and 7 is 1. That won't really help me change the numbers a whole lot, so I'm just going to work with what I have and multiply across next. 9 times 2 is 18, and 1 times 7 is 7. Oh, here we go again. The top is bigger than the bottom. There's an elementary teacher out there that I know some of you have worked with from Saginaw Township that will tell you the elephant is smushing the chicken. That's not very nice. So we need to turn this into a mixed number. We know that we have more than one whole because the top number is too big for the denominator. We again handle that, dividing the top by the bottom. 7 doesn't go into 1. I show you I tried with a 0 or a placeholder. But 7 does go into 18. It goes in there twice because 2 times 7 is 14. When you subtract, what's left? 4 parts. We are ready to go around the ring of fire, or perhaps to write this as a mixed number. I end up with 2 whole groups. And when I'm done, there are 4 little 7s left. I read this in the order, kind of like a clock, clockwise, 2 and 4 7s. Keep change flip, or this reciprocal method, will get us an exact answer every time. I do want you to be careful of a couple things. So just to point out here, did I ever cross simplify in division mode? The answer is no. You have to wait until you're in multiplication. So once you're in multiplication mode, we can cross simplify. So I do want you to tune into that. I also want you to pay attention to those numerators. If they are greater than the denominators, we have to divide. We have to turn them into mixed numbers. There's no more flipping. You can't keep change flip flip. There's not such a thing. Okay, just a keep change flip, and then we'll simplify as needed. I'm hopeful that on this next page you can continue that idea of keep change flip, so I know my students should be working on that. Some of these have whole numbers to start, some of these have fractions to start. It really doesn't matter. That method will work for all of these problems. The last thing I think I want to show you here is numbers 22 through 24. So I know students were just assigned a certain portion of this assignment, but I will give you an example here of what to do if you're working with mixed numbers. We do have an example like this in our notes, and again, your students' daily notes, your daily notes should be at home, and you should be using them as a reference. So what did we show you to do with a mixed number? Oh, we have to turn it into an improper fraction. Sometimes we call this macking. We're going to mack it. So just an acronym to help us remember. What that means is we multiply. If I have 5 whole bars divided into 2 parts each, that's like 5 times 2 is 10 little parts, plus the extra one at the top. So I get 11 over 2. I have 11 halves. So if I were to draw that out, I have 5 whole bars plus a little half more. You could count them up, that'd be 11 halves that you would see there. The next thing I have is that division sign, but another mixed number that needs to be mapped. So in order for us to divide or to multiply these mixed numbers, we have to rewrite them as improper fractions. Well, again, we multiply the denominator times the whole number and add the extra numerator to it. So 3 times 1 is 3, plus 1 more is 4, and we keep that all over 3. Well, this is division, and that's really good. I just did a rewrite step, but the next move would be a keep, change, flip. So I'm thinking Kcf to myself. We're going to keep the first fraction. I'm going to keep that 11 halves, and I realize it's improper, but we need it that way in order to do our fraction division rules. The next thing we do is we change from division to multiplication, and the flip of 4/3 looks like 3/4. Do you see any cross simplifying happening here? I don't offhand, so I think we're just going to multiply across and see what happens. 11 times 3 is 33, and 2 times 4 is 8. Oh, I got an improper fraction. So if you remember back to what I showed you just a moment ago, we'll divide the top by the bottom, and we're going to turn this into a mixed number in just a moment. So this is not a final answer, but I'll get you partway there. Notice you're going to have to try a similar strategy. You're going to have to turn any mixed numbers into improper fractions for number 24 and 23 as well. I think the last thing that you have there, I hope you are feeling ready for, maybe you don't even need my help on, but there are some word problems at the back. So I'll take a look at just a couple with you just to kind of give you hints and get you started, and then I do want you to be a risk taker and try a few on your own. So looking at number 25, it says solve, show your work, and also be sure to label your answers. Gina has 6 yards of ribbon. She cuts the ribbon into pieces that each measures 3/4 yard. How many pieces of 3/4 of a yard ribbon does Gina have? So I always like to think about the start. So we're starting with 6 yards. Notice it says she's cutting. Hiya! She's chopping them into pieces. That's really talking about division. And what size pieces is she using? Oh, 3/4. She's splitting them into 3/4 of a yard each. So let's set up this problem. This really says 6 divided by 3/4. Well, if you remember, we could use a bar model, or we could try a keep, change, flip, or reciprocal approach. So I would encourage you just to try this as kind of our strategy for right now. It seems to work every time, and it cuts down on errors with drawing or the pictorial approach. So I'm going to keep the 6, but notice it doesn't look like a fraction unless I write it over 1. All whole numbers could be written over 1. Change your division to multiplication, and let's do a flip with the next fraction. So it should read 4/3. I'm ready for my multiplication rules, and in my multiplication mode only, I can also look for cross simplifying, and I think I have some. If you notice, there's a common factor for both 3 and 6. They both divide by 3. 3 goes into 6 twice, and 3 goes into 3 one time. Well, 4 and 1, not much cross simplifying there. They both share a common factor of 1, but that does not change the numbers too much. So for that reason, we are ready to multiply across. Numerator times numerator, 2 times 4 is 8. Denominator times denominator, 1 times 1 is 1. This is the same as 8. But what were we measuring? 8 chihuahuas, 8 pizzas? Let me go back to the question and see if we can find it. How many pieces of 3/4 yard ribbon does Gina have? Oh, she made 8 pieces of ribbon. I do want you to be careful. I oftentimes have students that like to answer 8 3/4 yard. It kind of starts to look like 8 and 3/4 unless you're careful about how you word that or your separation of those two things. Maybe if you hyphenate the 3/4 of a yard, we can kind of tell that those are connected. I think we'll fast forward to number 27. Let's take a look at that before we call it good. Again, do whatever we have assigned to you today. Just use these as maybe examples or kind of, again, review if you need to check in and see that things are going well. But if there are other problems that I'm not showing in the video, that doesn't mean that you're excused from not doing them. Number 27. Johan has 3 sheets of wallpaper. Each sheet of wallpaper has an area of 12 square feet. Johan cuts the wallpaper into 1/3 square foot pieces. How many pieces are there altogether? Well, if you notice it says Johann has 3 sheets of wallpaper, it sounds to me like that's the start, doesn't it? But I know that out of each of those sheets of wallpaper, he can make 12 square feet. Interesting. So the 12 square feet is what he can make from each of those. So it's almost like saying, I have 3 groups of that, right? So 3 groups of 12 square feet. But then it goes on to say that he's going to cut them. Remember, cutting is talking about dividing. So he's going to divide them into 1/3 of a square foot each. So I might save this 3 groups for a little while from now. I might take care of the 12 divided by 1/3 because I've seen that before. If I were you, I would do a keep, change, flip approach. Multiply by the reciprocal. So to do a rewrite here, we would say that's like saying 12 over 1 times 3 over 1. And I want you to see what you get from that. So check for cross simplifying now that we're in multiplication mode, and see if you can simplify any of the numbers that are diagonal from each other. I'm not sure if we can. 1 is pretty low, like the limbo. How low can you go? Well, once you're ready, you're going to multiply straight across. Numerator times numerator and denominator times denominator. But whatever we get for our answer, that would really be from one of those pieces of wallpaper. That would be for each sheet of the wallpaper. So how many sheets of wallpaper does Johann have? Oh, remember he wanted to make 3 groups. So in order for him to make 3 groups, you're going to take this answer times 3. So 3 times whatever we get here will give us a final answer. I just kind of have you thinking about how this is going to be set up and how it's going to work without trying to give away the answer. Don't forget to give me a good label when you're done. So let's go back to the question. How many pieces? When I'm ready, I'm going to make sure that I label this with how many pieces Johann can make. I hope you're finding division of fractions possible in a couple of different ways. I hope you're using the strategy of modeling or pictorial approach with some success. And I hope that this keep, change, flip, or reciprocal method is something that you can glue in your memory, because it's something that will serve us kind of in all the years to come working with math.